All right, so we're going to do 1.2 today. And this is just factoring. There's a lot here to go over. I'm not going to do it all. I'm going to assume that when I say this is a difference of squares, you know what I'm talking about. All right. We all know how to factor a quadratic.
Yeah. Not a calendar. That's fine.
Okay. Spicy. So those ones I'm going to leave alone. Common denominator stuff, I'm not going to touch either. I'm going to go over higher power stuff like cubes and stuff, and what to do when you have like an exponent that has a fraction. Okay. Oh, cool! Look at that. We're up to date. No more expired gauze for you guys.
It's a shame.
All right. So let's factor. Done trinomials before. All right, let's do. Sums and differences of cubes. Okay, we've done squares before, now we're going to do the cubes. You can if you want. It's your diary, do what you want. Are you making it all uppercase? Good. What's that? Good, man. All right, so sum of difference of cubes is when you have a cube or two things that are being cubed that are being subtracted. I'm going to do this without numbers first. I'm going to use just variables, show you guys how it works, and then we'll do an example, okay? So a cubed plus b cubed. That's the sum of cubes. Okay? Now to factor it, what you do, you make your first bracket just a plus b. And then your second bracket is going to be a squared plus a times b. Is there 2 in there? Nope. Oh, easy. It's going to be a squared minus ab plus b squared. It's just what it is. Yeah. It's like this because this is what we do. All right. All right. A squared. Now let's look at a difference of cubes. A cubed minus b cubed. Thanks a lot. Cheers.
Cheers.
Now that's going to be a minus b bracket a squared plus b ab plus b squared. Chloe, chill out. All right, so there's an acronym that you can use with this stuff. And it's like foil, but it's soap. And what the soap refers to is the signs. The signs are same, opposite, always positive. Just like foil. I can remember learning foil when I was in grade 10, and I can remember learning soap when I was in grade 12.
Why isn't it just SOP then? Because always is an A. Why do you have to have always? Because
Because people remember soap over sop.
Like a-
Okay. Once again, same. Opposite. Always positive. Okay, so I'll do 2 examples that are going to blow your minds. Okay, I'm really going to have to get some posters in here for you guys for square roots and stuff. First example. (125x squared minus 8). Yeah. Now, everything here has a nice cube root because that would be mean to do that in the first example. The cube root of 125 is just 5. Right, 8 cubed, or cube root of 8 is 2. So all you do is you do this. You know that this is 5. This is going to just be x, same sign, minus the cube root of 8, which is 2. Times a squared. So I take 5x and I square it, so that's going to be 25x squared. Opposite sign, so it's going to be positive. A times b, so that's 10x. Plus, always positive. B squared. 2 squared is just 4. No, that was just double factor. I don't know if this could, I made this up, so I don't even know if it can go any further. Sometimes you can check this and maybe factor it as well.
And then take your first point.
Julie, did you get 8?
Minus 2. So
I think this does factor.
And they're coming six.
it's a part of the factor. 25.
Yeah, that's the answer. Okay, this was total fluke. I didn't plan on this. I made these numbers up. Super helpful, I know. Sometimes. When we get into calculus, being able to do this stuff helps a ton. It simplifies your work. Remember when we did radical or rationals in Math 11 or Pre-Calc 20? Like you cancel all that stuff out. We do a ton of that, and you take like you'll literally like I've had things that are like I write it and I got it right below, and then and then you're down to like x minus 2. Okay, so being able to do this stuff now makes your life a heck of a lot easier down the road. Okay. Now let's do another one. This one's always a little interesting. That was a negative, so let's go a cubed. No, don't do a. Sorry. Let's go x cubed minus, sorry, plus 6. Okay, now, first x cubed, same, so it's going to be x plus, now what's the cube root of 6? Maybe either. Yeah. Cube root of 6. So this is where, like when I was saying, don't just use your calculator to give you some weird decimal numbers, like leave it as a radical. This is where it was kind of.
Actually, I think it's the 126.
So there's a reason why you don't have your calculator in this class.
Yeah, and this is acceptable. Yeah. Right? Like you would write pi over 2 instead of 1.7 radians or whatever it is. And that's acceptable. Now, so you square this one. Opposite. You're going to multiply these two together. All right, x times cube root of 6 is just x cube root 6. All that radical and rational stuff from pre-calc 20s screaming back at us now. You could, like, I would accept this, or you could write it like this, x squared minus x plus 6 2/3.
Well, that makes it harder, no?
No, then you just leave it. Or you could write it like this too. Cube root. So you can square the 6 as well.
You get down to cube root 36.
Yeah.
Then you probably have to break it down.
The only things that I would know the cube root of at this point are 8
Yeah.
and 27, and none of those are factors of 36. So you just leave it like this. Don't try to do more with it than you have to. Okay. We're not there yet where you're gonna miss things yet. Okay. I don't need to show you that. We didn't do combinations, so you don't need Bernoulli's triangle. I guess I should show you one more thing. Now, I don't know if you'll ever need this or ever see it again, but it's a neat little parlor trick. You can show at parties if you want. If you're factoring like x squared minus y squared, we know that that's just x minus y plus x times y. I just showed you difference in cubes. X squared. Let's do difference of fourths. So same as before. Okay, good. No, it's same, negative, then all positive. Sorry, I didn't even scroll. Yeah. Okay, now I got to pat her back in my head. Well, it works like this every time.
Right.
I think there's like 2 or 3 questions that you might come across in here that this might happen. Do you guys see a pattern arising though?
Yeah.
I can't explain the pattern.
Okay, Brennan's right. It's getting bigger every time. Nothing gets by that guy.
There's more X.
So there's more X's and Y's. Boom.
It counts down from the number. Please,
The first
The first bracket is always the same.
Right? This is always the same. Cool. But let's look at this. Then, you know, x cubed, I got x squared, x to the 4, x cubed, x to the 5th, x to the 4th, right? The first one's always one less. And then if you look at my x's as I go along, so x to the 4th, cubed, squared, 1, then there's nothing. That's technically x to the 0. 3, 2, 1, 0. Yes, Brennan.
How do we tell where the one is what they call
I make it like
it?
the
Like the x cubed y.
x cubed y1.
Well, right there, there's x cubed y1.
Oh, yeah, now let's, okay, good. Let's look at the y's. After x to the 4th, there's nothing there, then it's 1, 2, 3, 4. Technically, you know what's right here? Y to the 0. So you start at 0 and work your way up. Here you start at 1 less than this guy and work your way down. It works for that for all of them. So you can, in theory, now do it's a lot of writing, but it would go x to the 8th plus x to the 7th times y plus x to the 6th times y squared, right? Right. If you look, like this is 3 and this is 1, 2, 2, 1, 3. If you add up these numbers, it'll always be this one here. 3 and 1 is 4. 2 and 2 is 4. 3 and 1 is 4. 4 and 0 is 4. Okay, this is a nice little pattern. If we would have had time in pre-calc 30, I would have shown you guys this. You're right, I was just slacking off. You got me. How are we doing for time? Okay, I don't want to take too much time on that stuff. I'm not going to go over synthetic division. You've already done it, and you don't really use it. Calculus 30. Let's do some common factor stuff, though. So I can take some x's and some y's and something that factors out of both 16 and 54 out, right? 54 is 9 times, I don't know. 9 times 6. And 16 is 4 times 4. Yeah, I can just take a 2 out of everything. Then I can take an x squared out of both and a y squared out of both, right? Now when you're factoring out variables, remember you subtract the exponents, right? 16 divided by 2 is 8. X to the 5th divided by x squared would be x. Good. Y squared divided by y squared. I'm changing that. 54 divided by 2 is 27. X squared divided by x squared is 1. X to the 5th is going to become x. Y to the cube. Oh, you totally could. Didn't even see that. Oh yeah, that's right here in the book. I should have read that. Yeah. Yeah, we can take the cube root of all this now. This would be 2x, same, 3y. Remember SOAP for the cubes. X squared, opposite, that's going to be 6xy. And then keep going. No. No. We're all done. Okay. Now I'm going to get crazy on you guys. Next example. 2x. No, I don't have 2x. Don't write 2x. That should be 3x cubed. Yes, the gentleman in the back.
For the one that you just did on the top 4x,
Yeah.
have you allowed different squares?
What do you mean?
Like take the factors of 4x squared. Oh wait, never mind.
You could, but not. You can't with this one. Yeah. Okay. Same ideas apply here. You can only take out the smallest variable between them, right? Like here, the smallest amount that was the same between both of these was like x squared, y squared, right? So that's all I could factor out of here. Same thing applies here. What's the smallest amount between these two? -1 is the smaller number, right? So I can factor a -1 out of every, x -1 out of both.
This would be left with x to the power of 4
And I can still take it. Don't give away the answer yet, Cole. And I can still take a 3 out of both of those. Agreed?
Yes.
Okay, so 3 divided by 3 is just 1. Cool. Now, what's the rule for division? What do you do with the exponents? So it becomes 3 minus -1, which is 3 plus 1. So it becomes x to the 4. 48 divided by 3 would be -16. X to the -1 divided by x to the -1 is just whatever. The negatives throw people off. A humdinger?
It's like you're on multiplying by 4.
Yeah, a difference of 1. But there's no fourth root. I don't know the fourth root of 16.
It's 2.
72 divided by 6.
Oh, yeah.
It's 12.
We're not going to do that.
Why not? But it's so much easier.
Just leave it alone.
So it's so much easier.
I'm
running out of room
and
and time. I haven't worked with these guys at all today.
Wait, I'm doing, and we need help.
Just you guys got to give me just a few
Yeah,
more minutes
after.
here. Okay. Now let's throw fractions into the mix with the negatives.
Everybody loves fractions.
All right.
Fractions are big. Grade 9, I'm good at fractions. Not that hard.
So look at the coefficients or the numbers. Common factor between 5, 15, and 10. Very good. I take 5 on this. Now, I need to look at the negatives or the variables here. The smallest one between all three of them is -5/2. Remember with negatives, the bigger the number is, it's actually smaller. So I've taken x to the negative 5/2 out of everything. So, do you guys want me to show my work with fractions, or can I just tell you what these are going to be? Brennan, are you okay with that? What's that? Jenna, do you want to see what I do with the fractions, or? All right, I like it. 5 divided by 5 is just 1. Negative 1/2. I'm going to show the first one. I don't trust you guys.
It's 2 o'clock. Yeah.
It is 2. Very good. 1 take away 5 is 4/2. Okay. This is going to be -3. Negative. That's going to be just x. Right? Factors of 2, -2, -1. Yeah. X minus 1 minus 2. Okay.
That's a beautiful answer.
Right? Well, it's x minus 1. Yeah.
No, I don't mean like the way you voted. I just mean like
How it looks in general. That's fair. It should be. Okay, that's all I got.
Okay. Let's see how it looks when you multiply by 5.
That would undo exactly.
It would undo everything.
It would, okay.
Just set this up.
You know what? Why would you put the 5 back in underneath the x minus 5 there, but next to the 5?
That's not what I was just doing. That's what-
Yes, Brandon.
Page 16. Oh, no. 9. Don't do all of 9, but you can do some of it. Do every other one if you want.
Okay. I was gonna do all of that.
And then 14.
9 and 14.
Well, 14 goes from A to T. For 14, I would do evens or odds or whatever. Okay. If you could actually, yeah, so do 10 of them. If you can do like every other one, especially ones with fractions and negative powers, like new stuff that you saw today, cool. I'm assuming you guys can handle quadratics on your own just fine. Okay, so all right, that's all I got. Stop talking.